Greetings. I've got this high frequency cat scarer which is supposed to stop the cats from coming into your garden and having a crap. Trouble is, as you can see, it doesn't always have an effect. Let's take a closer look. No, not at the cat turd. At the cat scarer. Here's the unit taken off the wall. Runs on a conventional 12 volt 500 milliamp power supply, which comes with a rather convenient 9 meters of cable. We've got this weatherproof cover, and underneath that, the unit itself. We have a switch here which switches between random mode and continuous. In random mode it just bleeps literally at random. Continuous it just constantly runs. On the side we have an on and off power switch, we have a frequency adjustment, and we have a power output adjustment. And on the bottom we have a connection where we can optionally fit a motion detector. We have two external speaker connectors. For some reason they're marked left and right, I don't know why. And we have the power input. Before we take a look inside, let's give it a run. Now hopefully the camera is picking that up. This is actually in its lowest frequency mode and its lowest output level. There it goes again. If I flip it into continuous mode, there we go. And it's sweeping through a range. In fact, it'd be worth getting the scope on that. I've hooked it up to the scope and the frequency counter. It's set for its lowest frequency, its lowest output power, and it's in continuous mode. I can hear that when it gets to this lowest frequency here, and now it's gone, and now it's come back into range for my hearing at least. We can see the output frequency in kilohertz. If I flip it to medium frequency, I can't hear that at all now, except maybe a little bit around about the 15 kilohertz mark. Almost like that feeling you get when a CRT TV is on in a room where you can't hear it but you know it's switched on. I'm getting that at the lower end, just about. And the high frequency, I can't hear a thing apart from that thing crackling. What's interesting is if I change the output level, that's 10 volts per division, so it's around about 12 volts each way. Medium power, it just squares the wave off. I'll flip it back down again. You can see it's just a squarer waveform. But high power, you get that, and also it seems to squeal. Almost like a swing in a playground. You can see that squealing seems to be coming from the speakers rather than the output. Whether it's the speakers can't handle this and that's how they're responding, I don't know. Drop the frequency down. That once again at the high end I can hear that almost like a CRT TV. Just to cover everything, let's put into medium. There we go, that's all the waveforms now. In random mode, you can see it just shuts itself off. Turn that off, there we go. You see at random, kicks in and shuts back off again. You can see now why I was using the attenuator. So that's the output. Let's see how it works. Here's what you see when you take the lid off. Obviously nobody wants you copying this design, because they've ground the tops off all the chips in an attempt to stop you figuring out what's going on in there. There's no component numbering. There is a part number on the board though, ASC 300 RGX 134. The speakers are just these out small tweeters. The lack of part numbering makes it difficult but not impossible. You can just make up your own part numbering and develop your own schematic like this. And from this you can also work out what most of the chips are. IC1 here is a classic 555 timer circuit, and this is the one which is generating the random mode pulses. Those pulses being used as an input into what I've got here as IC4, which is a logic gate. We'll come to that one in a second. IC2 is another 555 timer, and this is providing a fairly low frequency output, and this is determining the sweep rate from high to low frequency and back again. If you increase the speed of this, it would sweep more like a siren rather than frequency change. The output from that timer circuit goes into IC3. Now this isn't a 555 timer because it's being supplied on pin 1 and it's got pin 6 as its ground pin, and I have no idea what it is. The closest I've come to this is some sort of voltage control oscillator used for clock signal generating in a PC, but that won't run on 12 volts. This is. So I have no idea what this chip is. But that input is also pulled down to ground by 3 resistors and the frequency switch. As you can see, the lower the resistance, the higher the frequency. That provides an output then, which goes into this logic gate. And you can see that output from the first 555 timer, unless of course it's switched to constant mode, is used as an inhibitor. If that's on, both outputs are on. If it's off, then one of the outputs follows the input, and the other output is an inverted version of that. So the outputs toggle back and forth. Those outputs then directly feed these transistors, and the outputs then from those go through a set of resistors and to either the ultrasonic sounders, or if you plug a jack into the bottom, it'll go to the external speaker instead. So you can see from this that those earlier oscilloscope waveforms were only showing that way because I didn't have the speaker in there. Because I'd plugged in to measure the output, that was running off load. You can see basically it's got these resistors acting as volume controls. At low volume you've got approximately 2.8 kilo ohms of resistance in line with the speaker. At medium volume that drops to 820 ohms, and at high volume there's no resistance at all, it's just all dumped directly across the speaker. Now clearly my options for upgrading this are somewhat limited. I could upgrade the transistors, and increase the power supply, but I'd probably end up burning out these speakers. They can't cope with the maximum power output as it is. They just squeak like an old gate. But what I may be able to do is something using this external input. This is the one which is used for if you don't want to run it continuously and you don't want it running at random, you can have an external input such as a passive infrared detector. I don't have the proper passive infrared detector for this, and I can't be bothered to just get another one, just a normal off-the-shelf one, because then I'll have to waterproof the thing and it'll be a pain to actually get it all working. Water will get in there like it does with any other external PIR and it'll just knacker it up. So I want to do something different to improve this unit's effectiveness, and I've got just the thing. Microwave technology. That's a perfect deterrent for those pesky cats. And this is just the thing. What we've got here are 3 dual technology alarm sensors. These rely on both infrared and microwave. And what I can do, hopefully, is bypass the infrared portion and just use the microwave portion of the unit, which means I can tuck it away inside the case. On the left we have a Bosch DS820A, in the middle is an Aratec DD105C, and on the right an Optex DX40 Plus. Let's take a look inside. This is the DS820A. It's quite a slim board, but maybe not slim enough. There's plenty of room in the back of the case. But in the front of the case, bear in mind I want that microwave sensor to be in front of the circuit board looking out. There's not a lot of room there, so I think we can rule that one out. The Aratec DD105C, here's the infrared sensor. Normally this is mounted on the front, and when you put the lid on it'll plug in automatically, roughly there. The sensor is looking out via this mirror, and here's your microwave sensor which sits in this cavity here. Unfortunately it's a bit too thick. I think it's even thicker than the other one. And finally we have the Optex DX40 Plus. This is even thicker than the other two, but interestingly the microwave module is detachable. It's on the end of a 3-core ribbon cable. So I think we have a winner here. That module will mount in the front. If necessary, I can flatten some of these transistors down. I can move coils onto the back if necessary, or move the capacitors onto the back side of the board. And the bulk of it fits in there, because there's plenty of room in there. Awesome. What I need to do now is figure out how to access the microwave signal and ignore the PIR. Unfortunately, although I think the Optex was working when it was removed from the alarm installation, it doesn't seem to be working anymore. This only seems to detect now if you're really up close to it, like within about 6 inches or so. Much further away and it doesn't pick up at all. So I don't know whether I've broken it or whether it was already knackered. But that one is to go. Best use this one instead, which is the Bosch DS820A. The wonders of microwave technology, eh? If you live in a town or a village which looks like this on Google Maps, I think it's time to worry. This PIC 16C711 seems to control it all. Pin 10 is the control for the LED. There's a jumper on the other side which turns the LED off after it's powered up, so you can't see what the detector's up to. Pin 11 is the relay output, which is 5 volts normally and 0 volts when it's triggered. Pin 12 is for the green LED, and pin 13 is for the red LED. Both of those are 5 volts when the LED is active and 0 volts otherwise. The relay output would be ideal for driving the inhibit signal on that ultrasound generator, but we won't be going into full alarm. The infrared sensor won't be used at all, so it's never going to detect that and this. This will be seeing everything all through the plastic. This will see nothing, so the only thing it's going to do is light up the two LEDs, the red and the green together, to give you an amber output which indicates that the microwave's detected something. It's never going to show just red. What I can do is just take the green LED output, run that through a logic gate to invert it, and use that to switch the ultrasound circuit. There is another way of doing it though. If I replace that quad NOR gate with a quad NAND gate, as you can see, the inhibit function does exactly what I want it to do. When it's high, it works normally. When it's low, it locks the chip down. The result is just that it drives the outputs from the transistors down to 0 volts instead of up to 12 volts. I don't think it'll make any difference. Okay, here's what I've done. I've desoldered one of the legs of the chip here, the relay output leg, and bridged the solder pad on the board across to the green LED output. So the relay now follows the LED signal instead of the relay output signal. What this means is that every time it tries to run the green LED, which it'll do when it's trying to indicate the microwave signal as being present, because it illuminates the red and the green one at that point, it'll close the output relay contacts. And I've also taken the LED out and tapped off for the red LED there. On the board, I've replaced the IC there with a socket and taken the 4001 out and put the 4011 in its place. I've desoldered the input jack there because that was causing problems with the board connected, it was just locking it off. And on the underside, all I've done here is I've cut the tracks for one of the LEDs so I can drive that from this board instead. Tapped in the relay signal there to the input of that switch, and is taking the power supply from there as well. I'll just move the case off a sec so you can see what's going on here. When these start up for the first 30 seconds, they flash the light like that. Then it'll settle and the whole thing's active. As you can see, any movement, on it comes. Unfortunately, it's never that straightforward, is it? It turns out this doesn't like sitting behind there after all. If you put the lid on, it just runs and runs and runs and runs. Yet I can put this in front of the board, sticking out, and it looks fine. So what I've got to do now is try and make that board not as high profile. I've got to take some of these components, flip them around the back of the board to try and make some room for that. The board's now looking a little more bare because I've pushed all the components onto the other side. That will press down on that to hold the board in place, so it should all fit together. And even though that is missing this screw on the back, hopefully the fact that that's there will make up for it. Well, that was a bit of a squeeze. Unfortunately, the back cover of the circuit board is required. It's part of the microwave assembly, so I've had to shoehorn that in as well, which meant losing, unfortunately, the LEDs at the front. As you can hear, even at the minimum sensitivity, it's quite responsive. I've taped over any holes on the outside, and I've also taped over the screw holes to stop them rusting. Time to fit it outside. It seems that before the upgrade it was working better than I thought. There was a cat turd in the garden, but since taking it down there are now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cat turds in the garden. Obviously it was working quite well. With the microwave sensor I can now run it at full power, and hopefully that will act as a bit more of a deterrent, and I may well get it down to no cat turds in the garden. Fingers crossed. Thanks for watching.